Hey, it's Kyle again. This is the third in our series on hydrocarbons. Recall that in the second series, we talked about chain length and the impact on the solid, liquid, or gaseous state of the material. In this one, we're going to speak about saturated versus unsaturated. And this is a typical hydrocarbon molecule. Note that there's a hydrogen at every place there can be. In other words, each carbon is linked either to one carbon or to two or three hydrogens. There's an anomaly that occurs in nature, and that is there's occasionally what's called a double carbon bond. And this means instead, this carbon could have another hydrogen here, but instead it's linked up to another carbon. And this is the weakest part of this molecule. And we would call this a saturated molecule because there's a hydrogen every place there can be. This is called an unsaturated molecule because of that double bond. Now this is where the molecule is weak. Ultraviolet light, ozone, even mechanical forces can break these down at this location. And this breakdown is very important, and it's why motor oil viscosity deteriorates over time. It's why your body digests unsaturated fats easier than it does the saturated fats. And it's why skin cracks, fruit rots, all is related to these double carbon bonds. Now, just to make it so you'll remember this, let's just say you happen to go camping. And let's just say that for dinner there was a big stew with lots of the unsaturated fats in the stew, and everybody porked out and had a big dinner. Well, later on, when these unsaturated hydrocarbons start being broken down by your body's digestive system, and these Boy Scouts start releasing these ethane gases, it'll help you remember this better than anything.